Sounds good. Cool. Ready
And
to go?
we're good to go.
Cool. Well,
Let me
welcome
know.
everybody. Oh, sorry.
No, let me know when you want me to change the slides,
Okay, we'll do.
sharing the slides.
Welcome everybody. Good morning, good afternoon, good evening. Um, Today we'll have a fun session hopefully for all of you, and both Julie and myself will be presenting. Julian will do a couple of demos. And the main idea or the main section of this is to really talk about simplifying data for application developers. And so we'll walk through a scenario, and Julian, if you don't mind changing the slide. And of course, you have a familiar face here, Julian. He'll be co-presenting. Um, and I've joined him. I'm relatively new to the team, so this is my first JSON presentation. Been at Oracle before, just came from Visa and back at Oracle. So today we'll be entertaining you. If you go to the next slide, Julian will show us the agenda. Um, so we broke it up in kind of two sections. The first one is to what the title was talking about, which is really about if you build an application, you're not just done, right? There is a lot of data that needs to go into applications. And so we'll really talk about the use case, and then how do we tackle, for example, reference data in applications. And so we'll show you a little bit of a slides in the use case description. We'll talk a little bit through theoretically how we do that. And then Julian will do a demo on showing you some of the techniques or capabilities we talk about. Then we'll switch to a demo where we'll talk about some new capabilities. And then last, we'll close it out with an announcement of the Golden Gate from Mongo to Oracle migration tool. That's a free tool, and we'll dive into what that is and talk through the announcement. So let's start talking about the use case that we were talking about here. If you go to the next slide, Julian. So just to set some context here, a typical application stack these days is sometimes called MERN, but because this call has all J's, it has Julian, JP, and Jason. We'll call it Journ for the heck of it. The original thing is kind of Mongo, Express, React, and Node, and that's a very typical, I guess, modern application stack, right? That's how probably everybody on this call or their application development teams built their applications. You find some persistence layer. You take Node and Express, and then you put a React user interface on top of that. So these are the common set of components we use to assemble. The application developers really like the document or JSON storage behind that. Um, and one of the key reasons, or two of the key reasons actually, are that it nicely maps to the application constructs or the business constructs in the programming languages. And secondly, which is really important, it quote unquote cuts the dependencies with like your data architects, your DBAs, your relational database teams. And so this stack kind of gives the application developer full control, right? And if you think of agile development where a sprint is 2 weeks, everybody is kind of iterating through these applications. So people want to change the document structure without having to deal with all sorts of perceived overhead. So that's kind of what it is, right? And typically you hack together an application, let's say in a sprint, maybe two sprints, and then the app is done. Okay. So what are we talking about here, right? What's the problem? So if you go to the next slide, Julian. So what's the problem, right? The problem is actually the data. It's not the application data, right? Where I type in a set of information in my React application. I look at a bunch of stuff. That's all great. But both in my previous life at Visa as well as here at Oracle, and by chance I was looking at an application yesterday, it shows me a bunch of country codes, all two-letter things. And of course, I know that US is likely going to be the US of the United States, right? But there's a ton of them in there that I don't actually know. And if I'm looking for a specific country, it's a little tricky. Then they had states in there. And I live in the US, right? So I know the 50 states, or at least I know most of them, I think. But there's a whole ton of other things in there, and they're just like they're either numbers or two-letter acronyms or whatever they are. And so for most users and most applications to become at least usable, you need something called reference data. And that is where the fun begins, right? I've built the application, my little form works, I can type in my stuff, I can get it back. That's all great. But to make this really usable in simple scenarios, I just described it, or you need currency rates, you need currency conversions, you need all sorts of things like that. What you tend to need is something called reference data. And then the problems start. That's where the data problem starts. First and foremost, an app dev team now becomes a data integration team. And most of these teams are not really set up to do data integration. I'm not sure how it works in your organizations, but for us in my previous company, we didn't necessarily budget all of the wonderful ETL work that people needed to go do. We certainly didn't budget the discussions around which data do I need to get, how do I get it, right? And so your 1, 2, 3 sprint application development tends to get dragged out by any under budgeting or unbudgeting, right, of some of this work. It's also not app dev team's strength to go fish around data and build ETL jobs. There are skills to that. They typically don't necessarily have those. And then it becomes real fun if you mix like relational data and JSON, because now we're all happily, and while this all that sounds very simple, right? Now we all happily have to translate the relational data into JSON. We write an ETL job, we dump it to file, we put it on S3 bucket or wherever bucket we put it on. Now that data is just lying there, right? There's all of these fun things that start to happen when you kind of bridge like these two paradigms. The other thing, um, I remember when I said people like document databases because it cuts dependencies. You have kind of control over your data model without depending on anybody. This is exactly the opposite, right? We introduce a ton of dependencies. Um, you now have to go talk to your enterprise scheduler team. These jobs have to run every day. You have to put them in there. They'll tell you you can't move development data to production or production data to development, right? You get all of these wonderful things that those 2 or 3 sprints of app dev never thought about. And then, of course, the job fails. Your reference data is out of date. Now, that's less interesting for state codes, for example, of course. But if you look at currency codes, right, if you look at currency and the currency rates, they materially impact what is going on if you don't refresh them. So that's the problem with data, right? The problem with data is all of these fun operational things. You have to go get the data, you connect the systems together, and that's just the operational problems. Because the other thing, specifically in the world of AI and the world of GDPR and various other regulatory things, is how do you govern all this data? Right? How do you know who is subscribing to what data? And again, reference data is somewhat of the easy bit because that's typically state codes, currency rates, stuff that's not under GDPR or any of those protections. But as we all know, most applications also want to kind of embellish all sorts of other data. And Julian will have a fun demo with bank account number, for example. And so that's the problem with data, right? How do we deal with that? How do we solve some of the operational pieces? And then how do we make sure we know where this data is going and where it came from? And so your next slide, Julian. So what we're proposing here, we're going to semi-implement, is that we're going to solve all of this um, without, in brackets, and of course we will translate JSON, relational data to JSON, but without having to write ETL jobs to do it. We're not actually going to write an ETL job to move the data, but we're actually going to use the engine, the database itself, to do some of these things. And because we use these constructs, and because if you live in, for example, an autonomous database world, you would have a catalog, you'll have all of these capabilities that are connected to this system. And so those infrastructure and engine pieces are what we're going to use to move our data around. The other thing, and if we go to the next slide, Julian, is we really want to make sure that we understand where data is going, where it came from, that we avoid daisy chaining. I'm going to spend 3 minutes on that little picture at the bottom there and just kind of talk us through this because this is material from an architecture perspective. So the data consumer, think of that as the application, right? There's a little JSON database, autonomous JSON database for Oracle. And that's where your data product gets built or your application gets built. And you have your collections like students or sessions or all sorts of things. Doesn't really matter what the example is. But that's the data consumer. And they build a data product if you think in data mesh and various terms like that. And what we really want to achieve with some simple constructs like a cloud link and a materialized view and collections is that the data producer where the reference data lives becomes kind of a service. And so this database on the left, the data consumer, gets a cloud link that gives you a read-only connection into that data producer. And it exposes that as a data producer to that database on the left. It's read-only, so no need to worry about anybody messing up the data producer's data. Once that is established, I can now work on the publication bit of this. And this is where we isolate dependencies. The only thing we need is a cloud link into the data producer. And then on the other side, I'm quote unquote autonomous in the sense that I can build my publication structures. Now, there's a lot of discussion we can have about where the privileges need to be set, etc. But we're going to kind of go with the cut the dependencies as much as you can. And so you create a publication, which can be a view or a materialized view. And now you're exposing all of the data from the data producer into the consumer. And from there, you then translate the data and go into the collection view. And so that's the picture we're going to build up. And Julian, if you go next slide. And so this is kind of the steps we go through. Thank you. So create the connection, right? We talked about the cloud link. By the way, we use a cloud link because in this case, we're doing reference data, and it means it's a read-only connection. And so we don't have to worry about anybody by accident finding that cloud link and updating something on the other side. And so that's kind of our sharing pipeline, one way to the consumer. The second one warrants some thinking, specifically if you're the application development team. What we just done is we basically exposed the data from the producer to the consumer. And we're going to build an interface in the consumer side, which is going to be a view. But that means you see live data. And in some cases, that is good. But you have to make sure that the application development team understands that this is live data. Again, state codes don't change a lot. However, currency rates do change all the time. And so the question is, how do I expose this data to my consumer? Do I want it live, which means it continuously changes, and then the app kind of deals with continuous changing currency rates? Or, which typically is better in these application scenarios, do a batch scenario, right? You mimic an ETL job, and at noon every day or something, you replicate your reference data. And now you have a snapshot, and that means for the app, it's a lot easier to deal with. It just has a 24-hour window that the data remains static and the results remain the same. So once you've decided that, you pick whichever construct you want. Then, because we're in a database, and we're in an Oracle database in this case, you then decide what privileges do I want to give all the other applications on the data consumer side. Again, we chose to put it on that side because that cuts the dependencies. Now, for reference data, you really use a wide funnel, right? You basically say state codes, country codes, all of that stuff, just open it up, right? For more sensitive data, you can play with two things. Either you build an interface or a view or materialized view, which I call interface, and you just restrict data, right? You just don't include the columns, and that's what we're going to show in the demo. And that gives you instant protection of access, right? So now your data team doesn't have to think. They just go to these interfaces that you described for them or that they created, and they use those. And now they've subscribed to the right data. If you switch to the next slide, Julian. Now, this is where we start to transpose between two worlds. And it's a very, very, very simple step, which is the beauty of doing this in the engine, right? Rather than writing an ETL job that says select from this table, craft a nice text file that is a JSON format with all the brackets and everything, make sure they're all correct. We just set up a collection view, and Julian will demo that later. And then you just basically went from relational to JSON without doing anything other than creating a static quote unquote object. Now, the interesting thing about this again is not the creation bit so much, but it's the updating of everything. Here you update one object if you need to, whereas in an ETL paradigm, you need to update your ETL job, change the documents, make sure that whatever you spit out of that ETL job is correct, do your data testing, go from development to test to production, all of those things. This is a ton simpler, right? And you simply change your collection view if you need to and kind of move on with life. It also cuts again the dependencies and keeps your agile development pattern going. And then the rest is kind of like the verifying bits, right? Not going to go into too much detail here. But obviously, once you put the collection view in place, you check on the other side to make sure that in your APIs and in your document tooling, you can see the right things. And then hopefully you've thought about the catalog and have that all done, right? Because that's kind of the governance piece, which we won't go into today. And that kind of sets up the entire structures if you want to, from looking at the reference data, creating the cloud link, publishing it into the consumers set up their interfaces and structures, and then you create the collection views over the top of it. And as we say in America, Bob's your uncle. Now you have a data producer, data consumer, data product scenario that scales, that runs with agile solutions and goes from there. And with that, Julian, for the next slide. And with that, take it away, Julian, and we'll go run a nice little demo and show you some of these constructs.
All right. Let me share my screen first. All right.
Yep,
I guess you can see SQL Developer, right?
Yep, I can.
All right. So I'll take over from here just to show you with a simple example what JP explained. First, look at the database version. I'm connected to an autonomous database, 23.8. This is the latest RU. And this is an autonomous JSON database, so not very different from ATP. I'm going to create a table called JSON schema, JSON theme, and based on that table, I'm going to create a materialized view, just like JP explained. I'm going to exclude some columns, and then I'm going to create a collection view, a read-only collection view, and see how this works in practice. So let me first drop the table. I don't know if I have it. And as you know, in 23i, you have the syntax to drop a table if exists, so you wouldn't get a message. So let me also drop the materialized view if I already have it in the database. So let's create the table. Let's call the table JSON theme. We'll have an ID. We'll have a first name, nickname, last name, and we have a balance for the bank account of each one. A very simple table where the ID is the primary key. So here it is, JSON theme created, table created. And now let us insert some dummy data into the table. What I'm going to do is 4 rows, one for Beta, one for Herman, one for me, one for JP. And you see some have a nickname, some have a family name. We have also the balance, 100, 200, 300, 400, and we have some bank account numbers, just fake numbers. And as you can see in 23AI, you don't have to insert 4 times each row. You can do it in one go. So in 23AI, you can insert all rows with one simple insert statement. And let's commit in the database. Now, as I said, we can create a materialized view based on, well, let's see first what we have in the table. So here it is how it looks like. That is the table. So we have the ID, the first name, the nickname, the last name, the balance, and the bank account number. And now let us try to create a materialized view based on the table, but we are going to exclude the balance. And here is the syntax. So create material-wise view, build immediate, refresh force. We're going to refresh it automatically at noon every day. With row ID, enable query rewrite. So I'm selecting everything except the balance from the table. Very simple material-wise view. Material-wise view created. And now let us see what we have in this material-wise view. Of course, we have the same stuff like in the table, but we're not having anymore the balance column. We just have the bank account number. And let's just do a simple update so that we see how the data changes. For JP, let us update his bank account to 111111 and run a commit. And then I'm going to refresh the materialized view. So very simple refresh, just using DBMS MView refresh procedure. Refreshed and selecting from the materialized view, of course, with the updated data. So we have the materialized view ready. Now, what we want to do is to create a JSON collection view, which will exclude the bank account number. So this is part of the read-only database where you're only allowed to read the data. You cannot update it. JSON collection views are read-only views. JSON duality views are updatable views. And how we create JSON collection views, this is new in 23 AI. Here it is the syntax, and I'm going to use all rows in the table for the people who do not have a nickname. So that just nickname is not new. So everybody who has a nickname will be part. So we're going to exclude, unfortunately, Herman from the pack. And the syntax is create or replace JSON collection view. We give it a name, JSON team underscore CV, and we use the JSON function to create the data in the collection view. And the JSON collection created. All right. So what do we have here? We have the collection view in JSON format. Here it is. As you can see, we excluded Herman because he doesn't have a nickname. And we have Bida, Julian, and JP. And of course, this hides sensitive information such as bank account numbers and balance in the bank account. So this is for read-only purposes only. Very simple example. Yes, I think this is for now. JP, I'm going to turn over to you.
Mm-hmm.
Let me share once more the deck. And I have to go to the right slide, of course. So I guess this is the right slide.
Yep. There we go. So if you're now thinking, wow, that was simple, that's exactly the point of this to some degree. And like I said, in my previous life, it was extremely hard to get all these jobs done and built and scheduled just because of the processes to putting stuff into production. And what you just saw here is really quote unquote simple construct, right? A cloud link is a relatively straightforward concept. The things Julian did, we all know how to make an MV, right? That's like materialized view is nothing revolutionary or new. But I think we often forget about some of these things. Um, and here you can really kind of start thinking about data producers, data consumers, data products, right? Which is kind of the whole data mesh philosophy where you cut these dependencies, you build these interfaces. And often I think we forget when we go to data, we forget like kind of the programming rules, right? You always code against interfaces. Yet in data, we all seem to think we make some bespoke ETL job and whatever. What Julian just showed in a couple of base constructs that we all know and love is how to set up an entire kind of data interface structure by using materialized views or views, right? That's up to you based on your refresh rate or whether you want to see live data. And all of a sudden, you don't have all these dependencies. You can also build up these interfaces and saying like, well, here's the sensitive view, here's the not sensitive view. And while that sounds kind of a bit bizarre or even too trivial, it means that from a catalog and from a usage perspective, the application simply chooses. And now you have a documented lineage path of saying, I'm using not sensitive data, I'm using sensitive data. And by simplifying these building blocks that way, it's much easier to govern this. Right? And so we cut out a lot of the ETL jobs are running. The database orchestrates materialized view refresh. There obviously still sometimes can go wrong, but you don't deal with enterprise schedulers. You don't deal with secondary dependencies, all of that stuff. The other thing is we're not duplicating, triplicating, quadruplicating, if that's even a word, data, right? Because we dump it to disk and then we unload it again and then we put it somewhere else. This is all just live steps, right? They all just happily run and live within a database. You don't leak data. And so this makes the operations of this so much simpler. Um, and that was the point of making this demo not like super complicated, right? It is actually this straightforward. And so that gives us really this nice paradigm, cutting the dependencies, don't need to see deposit data in random places, all sorts of good stuff like that. And so with all of this, we then connect the JSON piece to it. Sorry. We connect the JSON piece to it, have the database convert this to these collection views. Again, all read only. And now you've breached, oh, sorry, now you have kind of like gone between relational and JSON. It now looks the way application developers like to see that data, and off you go, right? So simple, operationally sound, no dependencies, and you leave the database to translating to JSON. So win, 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 win. And hopefully that gave you a bit of context on how to set up some of these constructs. And with that, Julian, off to the next topic.
All right, thank you very much. So that will be a short demonstration. I want to show you how some not documented really 23 AI syntax works in the Oracle database, especially with JSON. Let me share again SQL Developer because I'm going to do it in SQL Developer. I'm showing probably a wrong tool. I'm showing Mongo Compass. I want to share it. I want to show SQL Developer. Here it is. And what is important is that in 23 AI, actually in 23.8, you can now specify the maximum size, and this is in bytes, of a JSON type column. As we know in Oracle database, the JSON maximum size is 32 megabytes. However, you can specify a size limit for a JSON column. You can, on top of that, you can constrain the array size, you can constrain the element type, even the storage order. And this can lead to more efficient handling of stored JSON data. I'm going to show you in reality how this works, because as I mentioned, I'm not 100% sure that the real syntax is documented. So first, let me drop, I'll do it with a table called test because it's just showing the syntax. For example, if you would like to create a table where the column should be limited, say, to 8,000 bytes, you can do it like that. Create table test, column 1 JSON, limit 7999. Here it is, table created. Why would you want to do that? In 23 AI, we are storing inline up to JSON documents which are up to 8K. So if you would like to make your application so that everything is inlined, and before that in 19C, it was 4K, now it's 8K, so you can use such syntax. There might be other reasons why you wouldn't like anyone to be able to insert huge JSON documents into the database. Now, let me drop this table once more. What you can do also is that you can limit also the objects in the JSON. You can limit them to 7K, for example. Here is a simple example how it works. And what else? You can also specify that all the elements of an array, a JSON array, are number data type. So the way how it works is that you specify that the column C1 is JSON, array consists only of numbers. I'll run the syntax. Here it is, the table created. Let me drop it once more. What I'll show you next is that you can do exactly the same. So the array will contain only number elements, but you can also allow null elements. So the syntax works like that: number allow null. Here it is, table created. I'm just verifying that the syntax works. And then you can also say that how many elements you can have in the array. So here I would like to have 22 elements at most. You cannot have more. After allowing null, I specified a number which shows the number of the elements. So 22, here it is, the table created. And the last one that I wanted to show, that you can sort also in ascending order also the elements. So you have to put also the word sort at the very end. I dropped the table, so let me create this one as well. So table created. So this is something that probably you don't find on the internet or anywhere. So if you want, you can see the recording later, or you can take a screenshot of how this works, and then you can really use it in case you're using 23.8 and you'd like to limit the maximum size either of JSON type columns, or if you want to specify a size limit for the column constraining array size, element type, storage order, and so on. So let me go back to the presentation, and we'll come with one announcement, and this will be done by JP. So JP, over to you.
Yep, you can get it to.
So
There we go. So as of this week, we are announcing the availability of what is called Golden Gate for MongoDB migrations. And this is a really cool way of moving your application from a MongoDB backend to an Oracle backend. You'll keep all of the amazing document features, but you get all of the good stuff from Oracle, including scalability and importantly, security and governance of the data. Now, this announcement, as it says, 100% free. It's a free license. You download it as a Docker image, and you have a browser-based tool that you see a little screenshot on the right there, that enables you to move collections out of Mongo and push them into Oracle. The nice thing is that you can either do this in quote unquote offline fashion, where you dump whatever you have in the database today and then you import it back into Oracle. And you can do that from the GUI. For like production or real kind of more important applications, you can actually use Golden Gate to sync. And so rather than doing a one-time cutover and shutting your app down and ponying it up on the other side, you can now do something that is practically done with all applications. You can run them synchronously. So you run your app on MongoDB, you set up your second app and run it on Oracle. You make sure everything's in sync. Golden Gate will nicely synchronize the data from, let's say, Mongo primary into Oracle. After a couple of days, you go, hey, everything looks great. The Oracle hosted app looks perfectly fine. Everything's good. You shut down the Mongo-based one. You kind of point everybody at the Oracle-based one, and off you go. Right. And so this takes a ton of risk out of migrations off of a Mongo backend onto an Oracle backend. You can see a number of other details there, right? Mongo 6, 7, and 8, whether it's on-prem or cloud, doesn't really matter. And like we said, this is free. It's a 183-day renewable container image. So you go to the container registry and you can see the link down there. If you just go to the Oracle Container Registry, you'll find the Golden Gate one. You download that one, and you can now use the single GUI and basically move your data away from Mongo and use Oracle with all the benefits to it. There is a MongoDB migration forum, part of the developer community. So if you have any questions about the tool, you want to start using it, you have a question on how to use certain things, please use that forum. And that's where everybody will be ready to help on using this tool to move from Mongo to Oracle. And so this is released as of this week, should be available in the registry, and good to go for moving off Mongo. And that's the last of that. So
I guess we're open for Q&A now, right, JP?
Yep. We don't have any chat questions, so
I guess that's it then. We don't have any questions. Oh, no, there is something maybe. There's something in the Q&A. How do you
how to
set
set
up
up
the
a
cloud link?
so a cloud link is a read-only database link. And if you're in the OCI console or the other clouds where we run database, there is a specific wizard or GUI way where you can go in and you can say create cloud link and you follow those steps. It's very trivial. We didn't actually even show it because it's like self-explanatory. It would be watching paint dry. But it's a capability that comes with Autonomous Database. It is in the console. There's a thing called Cloud Link. You can create a Cloud Link, and that basically publishes the data from this database as I had in that picture to a set of other databases. It's straightforward. It's documented. It's a simple GUI set of steps.
I don't see any other questions, JP, so I'm going to stop the recording.
Sounds good.